So for 5 electron group with 5 bonding pairs, the general formula is AS5. Okay, so the electron group arrangement and molecular shape for 5 bonding pairs is trigonal bipyramidal. Okay, so this is how the trigonal bipyramidal looks like. So we have a pyramid, okay, with 3 legs, okay, but we have 2 pyramids, okay, up and bottom. Okay, so we have 2 pyramids with 3 legs here. So we have the axial position and also the equatorial position. So the bond angle between the axial and the equatorial position is 90 degree, and the bond angle between the equatorial position here is 120 degree. So in 2D, this is how you draw the trigonal bipyramidal. Okay, so we have A as our central. Okay, draw the axial position of the surrounding atom, and then we have the equatorial position of the surrounding atoms. Okay, so if you can see, the bond angle between the axial and equatorial position here is 90 degree, but then between the equatorial position is 120 degree. So the bonding pair repulsion are equals in the 5 bonding pairs. So let's have a look at PCl₅. So the total number of valence electron is 40. Okay, so phosphorus is going to be our central atom. So we have 1, 2, 3, 4, 5 bonding. Okay, phosphorus bonded to the Cl. So we already use 2, 4, 6, 8, and 10 electrons. Okay, 40 minus 10, so we got 30 more electrons left. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. So we already used up all the electrons. So remember, phosphorus in period 3, so it can have an expanded octet because due to the empty 3D subshell. So the formal charge on all atoms is 0. Okay, there is no charge on the atoms. Okay, so the molecular shape, okay, in 2D is, okay, we have phosphorus, bonded to Cl in the axial position and also in the equatorial position. Okay, so put the bond angle 90 degree and also 120 degree. So how about 4 bonding pairs and 1 lone pair? So the general formula is AS4E. Okay, so the arrangement of the electron is still trigonal bipyramidal, but then the molecular shape will become seesaw. So this is from the trigonal bipyramidal. So I'm going to put 1 lone pair and then remove one of the bonding. So you can see the shape now will become a seesaw. Okay, kalau tak nampak macam ni, kalau kita buat like this, okay, nampak jongkak-jongkik kan? Macam jongkak-jongkik. So to draw it in 2D, okay, so let me draw the trigonal bipyramidal first. Okay, this is how I'm going to draw trigonal bipyramidal. But now, to make it seesaw, okay, remove this one and then replace it with a lone pair. Okay, so now the bond angle due to the repulsion between lone pairs, bonding pairs are greater than bonding pairs and bonding pairs. Tadi kita ada 90 degree dekat axial and equatorial. So now it will become less than 90 degree, and also at equatorial position tadi kita ada 120, so now it will become less than 120 degree. So let's have a look at SF₄ as 4 bonding pairs and 1 lone pair example. Okay, so we have sulfur as our central atom. Okay, and then we have 4 fluorine atom bonded to the sulfur. Okay, so we already use 8 electron. Okay, So 26 electron left. Okay, so we put into the we put on the surrounding atoms, and then the 2 electron left, we put it on the central atom. Okay, so the formal charge on all atoms are 0. Okay, so in 2D, the molecular shape is the seesaw. So this is the seesaw. Put the surrounding atoms, and then the bond angle due to the repulsion of lone pair bonding pairs are greater than bonding pairs. It will become 90 degree, less than 90 degree, and also the equatorial position is less than 120 degree. The next one is 3 bonding pairs and 2 lone pairs. So the general formula is AX3 E2. So electron group arrangement still in trigonal bipyramidal, but then the shape will become the T shape due to the repulsion of lone pairs greater than lone pairs, greater than bonding pairs repulsion. So here is the trigonal bipyramidal. So I'm gonna add 2 lone pairs and remove 2 bonding. Okay, so as you can see here, okay, the shape now become the T shape. Okay, so we have the T shape. So to draw the T shape in 2D, okay, so originally this is the trigonal bipyramidal. So I'm gonna remove these 2 bonding and then replace it with 2 lone pairs. Senang sikit. And then put the bonding here. Okay, so since the repulsion of lone pair are greater than lone pair bonding pairs, or greater than bonding pairs, so the bond angle here will become less than 90 degree. For certain book, they wrote it as approximately 90 degree. Okay, dia menghampiri 90 tapi dia bukanlah tepat-tepat 90. So for example, if we have ClF₃, chlorine trifluoride, okay, so this is the Lewis structure of ClF₃, where the formal charge on all atoms are 0. Okay, so here we can see that ClF₃ got 3 bonding pairs. Okay, we have 3 bonding pairs and 2 lone pairs, so 5 electron group. So to draw the shape, okay, so this is originally the trigonal bipyramidal, and then as usual, I'm going to remove these 2 and then replace it with 2 lone pairs, okay, so that we can have a nice T shape. Senang nak hafal dia punya lukisan kalau kita based on the the basic structure trigonal bipyramidal. So the bond angle here will become less than 90 degree or approximately to 90 degree. And last but not least, in 5 electron group is 2 bonding pairs AX2 and 3 lone pairs E3. Okay, so arrangement is still based on the trigonal bipyramidal, but now the shape will become linear shape. So again, this is the basic shape from trigonal bipyramidal. So I'm going to add 3 lone pairs and remove the 3 bonding. Okay. Okay, so as you can see, it will become a linear. Okay, so the bond angle is 180 degree. How is that possible? Okay, because the lone pairs is on the equatorial position. Okay, so dia dekat sini, so sejauh mungkin yang kita boleh arrange our electron in the bonding pairs are in 180 degree. So in the 2D, okay, so this is the basic trigonal bipyramidal. So you can see that I'm going to remove the electrons, the bonding in the equatorial position and then replace it with the lone pair. So we have 2 lone pair here and 1 lone pair there. Okay, so the bond angle will become 180 degree. So as example, if we have I3 minus, so one of the iodine will become our central. The formal charge on the central atom is -1 because 7 minus 6 minus 2 is equal to -1. So our overall charge is also -1. So in the 2D, okay, to draw the structure, all right. So this is the basic trigonal bipyramidal, and then remove all the 3 bondings on the equatorial position, right? Okay, so here we have 2 lone pairs on the left and 1 lone pairs on the right, and then the bond angle is 180 degree. Okay, so since this is a negatively charged molecule, so put the negative charge up, or you can put the charge on the central here, I minus, just like that. Okay, so tak perlu pun letak gulungan dia pun tak apa. Okay, so senang kita letak I minus dekat atom dia terus. So that's it for the 5 electron.